Okay, so this is going to be a quick lesson in something that we've already done. We've already done some estimating quotients. Okay, so for instance, I'm just going to make a totally random problem on the back. If I have 237 divided by 8, we learned to say that it is still divided by 8. We keep that the same, and that we look for what 8 works easiest with. So we kind of 8, 16, 24, it's multiples. I see, wait a minute, what if I made that a 24 with a 0? And so I would say that is pretty darn close, but now I can do it using my basic facts. 24 divided by 8 is 3, carry over the 0, so about 30. Guys, the only difference today is, let's think about our vocabulary. This is a dividend, and this is a divisor. The only difference between topic 4 and topic 5 is the divisors are getting big now. Okay, so instead of just being divided by 8, it's going to be bigger numbers. Okay, but same strategy. Okay, so we're going to be using compatible numbers. Now, I know I've heard a lot about this, but that was when we talked about compatibility, about numbers that get along well. They work well together. They're kind of like soulmates. Okay? Another way I like to think about it is, like, think about fact families. Think about numbers, because fact families work well together. For instance, like, when I think of 8 and 3, 24 works nice and easy with it, right? Okay? Whereas numbers like 7, 2, and 13, well, that's not a fact family, and they're also not really compatible. So thinking about numbers that have a magic spark, that work well together. Okay? So now I'm going to look at this problem. If I had to find an estimate for this, I want to show you that I think some of you sometimes say, oh, I'm not good at making estimates. And it's not because you're not good at it, but there are right answers, and then there are like really accurate answers. And so we want to try, I know that a lot of us make these, and then we miss the best estimate. So we want to try to make the best estimate. So first I'm going to show you what I would say would be the best here. Now, I know we were keeping the divisor the same a lot, and if you can, that's great. But when I think about what 75 goes into, I can't really think of anything close to that. So instead of it being 75, I'm going to say, well, wait, what if I make it 80? And what does my 8 go into? 8, if I do the multiples, goes into 16. What if I make the dividend 160? Because, guys, then I'm searching for my basic facts. That's why I put this here. I'm searching for my basic facts. I see 16 divided by 8 is 2. Annex the zeros. The estimate is about 2. Okay, that is the best estimate. I want you to look at a decent estimate. It says better. I had good, better, best. It's decent. It's like an okay estimate. It's not perfect. It's not the best, but it's okay. You might say, oh, what if I just do, I made that divided by 80, and I said, oh, I could do, what about that? Is that terribly off? No, but it's not really like 24 divided by 8. Yeah, that works. Okay, and your estimate's about 3. It's not that different. But can you see why making this 160 divided by 80 is a lot closer? It's not too much of a change for the divisor. It's not too much of a change for the dividend. This, it's not too much of a change for the divisor, but I would say that's a pretty big change for the dividend. Guys, the less you change, the better. Okay? The closer the estimate. Alright, so now you are going to do some problems on your own. Okay, so this is some work for you to show what you know. So I want you to go ahead and get started on that. This is for you to do, so I'll do the first one with you. Okay, so I'm going to go ahead and say, what if I make that divided by 40? Okay, what's 4 going to? 4 goes into 24. Ooh, 4 goes into 28. So what if I made it 280 divided by 40? 4 goes into 28, so 28 divided by 4 is 7. My smart estimate is about 7. Okay, so I want you to do this, the last 5 on your own, and then I want you to see why estimation is so important. These, I know we call them a lot the smart estimates. These smart estimates that we're making, that we just made on this page, we made a smart estimate that this is going to be about 2. We made a smart estimate here. You're going to make more here. Why do we do all this and not just solve exact? Guys, smart estimates help a lot because, look, when you have problems later like this, does 30 go into 2? No. Does it go into 22? No. Oh, are you kidding me? I have to see how many times 30 goes into all of that. If you made a smart estimate to start, then you have an idea of where to go with this. Otherwise, you're like, ugh, do I have to count up? Also, with your area models, if you make a smart estimate and then you go to say, okay, something times 18 is 270. So I've got 18 here times something. It's going to get me 270. I don't even know where to start. But if you make a smart estimate, these smart estimates help give you a good clue as to where to start. Okay, so they're very important. It's not just something that I'm making you to do just because it's, you know, it's lesson 5-2 and you have to do it. It's actually very beneficial. Okay, so I want you to go ahead and do your practice. Okay, we'll check our smart estimates. We'll see compared to other peers if you get different smart estimates, whose is the better version, but whose is the best version. Okay, try to identify that, and then we'll move on. All right. When you finish this, feel free to also move on to task time, and if you finish your tasks, you are on to early finisher. Good job.